In this problem, we are asked to determine the perimeter and area of the composite shape shown below. And if you look at it, it kind of looks like a heart, doesn't it? Well, let's start with the perimeter first. Because we're dealing with a composite shape, we want to recognize that there's actually two pieces that go into this bigger shape. The first piece would be these curvy parts here, or if you like, we have one semicircle here sitting on the left side and one semicircle sitting here on the top. And specifically, I only traced the outside part because right now we're focusing on the perimeter. And perimeter is the distance around the outside of the figure. So I'm going to focus down here on this part, this semicircle part here, and on this semicircle part here. Afterwards, then I'll focus on the rest, which is, if we like, a square. Do you see that? Is a square down here, and we'll specifically be focused on these two sides of the square. All right, so let's start with that circle part. Notice I have half of a semicircle, and I'm going to write that down. I'm going to write down semicircle because I'm saying it, but let me write that down. A semicircle, which is half a circle, right? Half a circle. And I have a half that's sitting here on the left side of this square and on the top of this square. And I actually was working this problem in class, and a student said, well, let's just put those two halves together and make a whole. And I thought, what a brilliant idea. Let's look at this problem here like two halves, two semicircles put together to make a whole, right? We have one on top, one on the side, and if we put them together, it gives us the whole. But specifically, we're looking to calculate the distance along the outside here edge of this semicircle. And that would be the distance that corresponds to this whole circle that we've drawn. And we've got another piece here, and we're going to calculate this distance, and sure enough, that corresponds to the distance here on the upper part. So really, to get the perimeter part for the red line or red curve that I've shaded, we simply want to get the perimeter of this circle. And what do we call the perimeter of a circle? Do you remember that a perimeter of a circle is called circumference? So the circumference of the circle is the distance around the outside of the circle. It's the perimeter of the circle. And the formula for circumference comes in two fashions. It's either pi times the diameter, or pi d, or it's 2 times pi times r, the radius. And we've gone over this in class. Whoops, excuse me there. So it shouldn't look too bad. So circumference is either pi times the diameter or 2 pi times the radius. Now, which of these would be more advantageous to use in this problem? Well, first we have to figure out, do we have a diameter or a radius? That is, do we have a distance all the way across that circle? Well, let's go look. Notice the diameter of the circle would be represented as this distance here, which is equivalent to one side of that square that we're looking at. And so, sure enough, we do know how long that side is. That side is 8 inches. That means the circle that we're talking about has a diameter of 8 inches. Since my diameter is known, I'm going to select this top formula, pi times d, and use that as the formula for the circumference. So circumference equals pi times our diameter, which is 8. And there's one little bit here we want to point out, that at the bottom there's a little bit of instructions that say use the pi button on your calculator to make sure your answer is as accurate as possible. Round your answer to the nearest hundredth as needed. So if I want to take 8 times pi and get an approximation that's as accurate as possible, I'm going to use that pi button on my calculator. If you're using Desmos, recall that pi on Desmos is simply the word pi. So you just type pi and it gives you pi in Desmos. That being said, let's take our pi button on our calculator and let's multiply it times the number 8. And the infinite decimal that you should get is approximately 25 .13274,123. And remember, this is an irrational number that goes forever and ever and ever and never repeats. But that's enough digits for us because we're only rounding to the nearest hundredth. This then represents the circumference, or the number of inches that are traversed when I go around this red portion of my composite shape. That brings us to the lower part, or the green sides. So that's what we're going to talk about now. To get the perimeter for the lower part, or the two lengths that are straight right here and straight right here and meet at a right angle, I want to refer to the bottom shape. And do you notice that the bottom shape is a quadrilateral, right? 4 sides. All of the sides are equal and there's right angles involved. So this shape right here is a square, right? So we are talking about looking at a square. So that bottom shape's a square. But for the perimeter for our particular heart shape, we only want the outer sides, right? I'm going to trace it again. The heart shape is only on the outside, not on the inside. So when I'm going to talk about the perimeter, I really only need to focus on this lower portion of the square and this side portion of the square. Those are the only two that are coming into play when I'm talking about the perimeter that I want. So it'd be this side and this side on my square. The other parts we don't need. So I'll kind of just erase them and get rid of them, all right? So let me just get rid of those, okay? And just keep the two we want. Now, how long are each of those sides? How long are each of those sides? Well, we have a square, don't we? So opposite sides are equal. So that means 8 inches on the top will correspond down to make 8 inches on the bottom. And 8 inches on the left corresponds over to 8 inches on the right. So that means our square is 8 inches on the bottom side and 8 inches on the left side. We only want those two pieces, and so that piece of the perimeter is simply going to be 8 inches plus another 8 inches, which is 16 inches. So that's the contribution for the green portion on my perimeter. Now, putting it all together, we want to put together the two red sides, the red bumps, and how long is that? If we went and measured that, that's 25.13274,123 approximately inches. And then if we added this distance and this distance, that adds another 16 inches. So in our calculator, we want to combine these two values, 25.13274123, and add it to 16, and that's going to give us a total approximation for our perimeter. When we add those two numbers up, what do we get for that perimeter? That perimeter of our composite shape is approximately 41.13274,123 ... Rounding our answer to the nearest hundredth means the second decimal place. So we're going to focus right here, look to the right, that number's small, so we're going to keep the 3. And that tells me that the perimeter of this composite shape is approximately 41.13 inches. Oh, that was a lot of work just to get our perimeter. Now we have to do the area, but I'm going to stop this video here and then put the area on our second video.